Theoretically, if the Earth really were a globe, you could do angle measurements. Why wouldn't you be able to?
You can't have a 90-degree angle to a curved surface.
You can't use elevation angles alone to measure height on a globe because you need a triangle with a flat baseline with a known length to the GP of the object in the sky.
Today, we don't use much of celestial navigation to navigate through the waters of the ocean, if you can imagine.
You don't think people go out on the water with sextants and they don't have them as a backup on aeroplanes? You don't think that's the case?
Oh, no, they absolutely do.
Yes, that's right, they do. So we're aware of celestial navigation then. Angle measurements can only take place on a flat Earth. Further to this, all of the models and maps, including the globe.
Wait a second. Why wouldn't you be able... I mean, you'd have to know the distances, obviously. So
selecting the arc, scroll down. So almost 600 miles shorter.
Theoretically, if the Earth really were a globe, depending on the distance of the stars, you could do angle measurements. Why wouldn't you be able to?
You can't have a 90-degree angle to a curved surface.
And depending on the size of the Earth. Now, if we're presupposing the size of the Earth and presupposing all the distances, then yeah, I mean, that's a burden of proof. You know, whoever's claiming those distances would have to prove that. But to just unequivocally state that, that would be an appeal to extremes.
Where it meets the Earth. You can't have a 90-degree angle to a curved surface.
You can't use elevation angles alone to measure height on a globe because you need a triangle with a flat baseline with a known length to the GP of the object in the sky.
To briefly touch on what the guys over at Flat Earth Debate have been saying. If we're standing here on the Earth, this is the angle to the celestial body from our position representing the horizon. The angle formed here is definitely not 90 degrees where it meets the Earth. You can't have a 90-degree angle to a curved surface. And AutoCAD will actually verify this. I picked this line and this line, it will give me an angle between them. If I try to pick this line and this arc, it says here, object selected is not a line. So it will just not give me an angle. And why would it? How could it? The angle will be different every single point on that arc.
Theoretically, if the Earth really were a globe, you could do angle measurements. Why wouldn't you be able to?
To the people who believe we live on a globe, where are you getting your 90 degrees? Where are you getting your straight line to form the 90 degrees? Where are you getting your circle of equal altitude? Because from what I'm seeing, none of them are available to us using a sphere. If we are truly living on a globe, then we need to be able to triangulate our position on a globe, and it just doesn't work. So there's absolutely no possible way you can triangulate your position on a globe. The reason we use a flat map, and it works every time, and has done for the last couple of 100 years, is because the Earth is flat.